I'm CK. Today we have another kit in the ever-expanding Edu line from MKI and Erica Synths. Today it's the BBD, Bucket Brigade Delay, reminiscent of the initial transistor-based delay units. We'll put it together, take a look at the web page, because again, the user guide that comes with this is as valuable or more so than the kit itself for how much it explains about theory and how the device actually works. Go download that. Even if you don't get the kit, you can get that for free, and well worth it. They should charge for that. So we'll put it together and hear how it delays, and I hope you enjoy the video. Pick this up from thonk.co.uk, as I do most of my modules. Looking forward to another Edu series kit, and I'm going to sneeze. Audio skip. Let's open up the box after my sneeze. We'll look at those in a second. We'll look at those in a second. We'll look at the power cord right now, because sometimes, yeah, see, they're still doing it. Come on, guys. Please, please, I beg you. Don't use this little dotted line, little red speckles. Do a solid, get them with the solid red line. Again, if I'm behind my rack where it's dark, or if you're in a club setting up or something, that's hard to see. I will never give up talking about that. Okay, here's the front panel. It has delay time and CV level for the time delay you put in, feedback level, wet dry, input gain, range, time CV, so you can control the time and it's set by that level, inhibit CV, I'm not sure what that will be. This is audio in, wet out, and mix out. So I don't see, oh, there's the dry wet. So you can have a full wet coming out, or mix, or you can probably pick up both at the same time, which I can certainly see as being useful. Nice board. It is surface mount quality. All the component values appear to be on the board. They do. Version 2, September 2024 for the board. Schematic by Moritz Klein. PCB by Ingus Petrus, Erica Synths. On the other side, same schematic by Moritz Klein. Yeah, same thing. And the other thing that they do, they have a bunch of test points on the board, so be careful never to put one of your components in there. So that's the board. Looks pretty straightforward. Here we have some mechanical bits. The knob has got a metal insert with a set screw, which is great. It's a great knob then. Nothing particularly unusual there. Now we'll look at the chips. We've got TL072, 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 so those are 3 op amps. Interesting that he uses 072s instead of putting 1074 or something in, but that's dandy. Resistors, Zener diodes, more resistors, lots of one-off resistors. 1Z, 2Z, guys. Let's see, here's the main thing. V3205 Sierra Delta SD. That's probably the delay unit. I'll look this up. I'm not familiar with that chip. I haven't used that chip before. And here's another CD4046BE. That's probably a counter or divider. I'll look that up in the interval also. So as you can see, nothing particularly challenging on this probably. It'll probably go together pretty simply, but there's enough to do if you're just starting out to get good experience with this. And I'll get the soldering iron heated up, get the build guide, and we'll put this fella together. I looked up the two chips, and the V3205SD is the actual delay chip from Cool Audio, and the CD4046 is not a counter, it's actually a phase-locked looper. So that's what those chips are going to be doing for us, doing the actual delaying of the signal. Now, why can't I pick this up? There we go. I'm putting the chips aside so I don't mess about with them. And as I expected, the build guide or whatever tells you everything that's going on here, and describes exactly how the technology works to get the delay in. It shows you how to it shows how it buckets it along, buckets the samples along. That's why it's called the Bucket Brigade Delay. And shows you how to breadboard all this with the parts that come in the kit if you want to breadboard it before you actually assemble it. And all kinds of stuff. You'll learn a ton just reading through this manual. And again, the manual is free. I'm going to scooch ahead and take a look at the build guide part of it, which is probably pretty simple because there's not a lot of parts and there don't appear to be anything particularly unusual about any of the components we've got here. And again, it goes through all the actual components you're going through and describes them, from transistors to op amps to capacitors to resistors, all that stuff. All very good. Okay, blah, 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 blah. Good schematic. Pictures of the board, which is always helpful. And now, it just says first put the resistors, diodes, and the diodes on. I know I said diodes twice because some are switching, some are power protection. And I'm going to sneeze again, so there'll be an audio skip here. And we're going to start with the 100K resistors. Am I centered? No, I'm not centered. Let me get centered. We'll grab one out. Actually, let's just get them all out. And first thing we need to take a look at is, oh, these are, golly, I forgot, as typical with the MKI boards, they're all stand-up resistors, which, as you know, I don't like very much. I think they're prone to error, but bottom line is, I'm sorry, I'm looking at this and trying to, this is why they've got the diagram in here, because I'm going to start out with these 100Ks, and here's R22, and here's another resistor, and there's only one label here that says 100K, so I'm going to have to go back to this. And they're both 100K, so this 100K writing is for this resistor and this resistor. That's why it's important that this page shows the actual placement. So we bend the top lead over, put the body through the hole with the circle around it, and the other end goes like so, so it stands up like that. Again, I don't like these because You can, it doesn't happen often, it happens extremely rarely, but you can bend them over and potentially ground them or break a lead or something horrible. So, and it's particularly the case, in my opinion, with eurorack modules because you're often swapping them in and out. It's different than inside a radio case where you're never going to touch the components, but the nature of swapping eurorack components on your rig all the time means you're going to be touching the componentry a lot, and every time you touch it you have a chance to bend these, because again, pots and knob and jacks are here. This is all hanging out in the open, so when you reach around to put the power cord in to do whatever, you have the potential for contacting that. But as you just saw, the solder flows very well on this board, so I'm going to go ahead and put all the resistors on, and there's a good number of them. And since I've already talked about resistor positioning and how this stand-up resistor style works, I'm going to mute the commentary, speed up the playback, probably cut some of it out, so you can enjoy resistor time. That's the end of resistor time for this kit, and you'll notice he's got 1, 2, 3, 4 lie-down resistors along the way too. So we've got both types of resistors, so what that means is don't just randomly bend the leads until you know where things are going. Now we'll put the polarity protection diodes on, the 5819s that he's using, and there's a white stripe on the circuit board to tell you where the silver stripe on the diode goes. And there are 2 of them. And if your module doesn't work, first thing you should check is to make sure you put the diodes in correctly. I have certainly made that mistake at least once in the past 60 years. Now we'll put all the 4148s, I think they're 4148s, or is he, no, yeah, they're 4148s. They've got a little black stripe on them to show the polarity, where the cathode side of the diode goes. And there's the diodes all on, and I'm going to go back to what he would like to do. I think we'll do the sockets. Yes, we'll do the sockets. Sockets usually come after all the flat components, and we've got a bunch of them to do. Oops. And there's a little notch on the socket which you want to line up, put on the same end as the notch that's on the circuit board. I'll take a little card. Oops, I can't do that because these are stand-ups. I forgot. Golly, I should have put the sockets on first. I screwed up on that. So what I'm going to do, well, Okay, we're going to have to do these one at a time because I typically lay this flat on my workbench after I've put the sockets on, and do the legs that way because they just lie flat. But because the stand-up resistors are taller than the sockets, we're going to have to do it this way. Go here, do one leg, make sure it's all flat, move on to the next one. Again, being sure to keep making sure that the notch is in the right place, even though I will say when you're finally putting the chips in later on, I always kind of ignore the socket and look for the printing on the circuit board, because the printing on the circuit board is the truth where the socket could be misinstalled. So that's all the sockets. We're not going to put the chips in them yet. Next we're going to do all our caps. And first I'm going to pull out all the 104. Tenth of a micro decoupling caps. Most of the time, if you have IC packages like these op amps and the looper and the delay itself, they're going to take a one or two of the 104s as decoupling caps to condition power for the IC, give a little buffering, also give a little, oh, I didn't solder that side of that, I didn't solder that socket. I gotta do that right now before I forget. So they give a little buffering of power in case there's a voltage sag or peak. They also can filter out a little bit of circuit noise. You can find many good references for what decoupling caps are for online or in textbooks or wherever. And I'd encourage you to take a look at it because they're so ubiquitous that you're going to run into them all the time. And it's always good to have a little bit of understanding about what all the components are doing, of course. You don't have to be an expert to build electronics, but part of the fun of putting things together is learning what they do. All the decoupling caps are on, so now we've got three more ceramics of various types. We've got a 221, two 221s, and a 102. So we'll find the 102 first. I think I saw it down here, 1 nano. And that's the 220. Because 221 is a 2, and 1 0. So that's 220 picofarads, which is what they are labeled in. And that's all the ceramics. Let's see what he would like us to do next. Oh, okay, he wanted us to do the flat resistors first and then the stand-ups. Okay, that makes sense. That's my fault. And next we're going to do some electrolytics, the voltage regulator and the transistor. But right now, the cats are scratching at the door saying they want to get fed, so I'm going to go feed them. All right, now we're going to do our voltage regulator and transistor. Let's see what we've got. We've got the 78LO5, which is the 5-volt voltage regulator. Let's see where that goes. There it goes right there. And the middle pin goes forward instead of aft on this one, which is different than many implementations. But just make sure you match the flat side of the voltage regulator and transistor to the flat indicated on the circuit board, and you'll be fine no matter which way the legs go. And here we've got that one, and this is a JCJ 113, and that's what we got here, 113, so we're good. And again, center leg goes forward. Now we're going to do all the capacitors, the foil caps, and the 4 electrolytics. We'll do the foil caps first. Double checking the parts. Yeah, okay. And again, when you get these in paper tape, don't try and tear them out. Just nip them out, because you'll drive yourself a little crazy bending the leads and so on, potentially even tearing them loose from the packaging if you're not careful. So just cut them out. Easy as pie. And these are, of course, non-polarized. So put them any old way you like. Now we'll do the electrolytics, and again we got 4 of them, so let's start with this one that just popped into my hand, 47 microfarad, and these are polarized. The long lead is, oh, they're different ones, I think. This is 25 volts. Well, that's interesting. I'm sorry, I want to see what I've got here. Because we've got 2 47s at 25 volts, even though the board says, the diagram says 16 volts. And they both go down here, and you'll see there's a flat line on these. That's indicating where the negative side is. And I just put it in backwards, and that's no good, so we'll put it in correctly. So we have slightly more, we have a 25 volt tolerance or working voltage, max working voltage on these instead of the 16 that they say in the build guide. And these 3.3 microfarads are 50 volts, where these are listed at 16 volts. So we've got slightly upgraded parts. I mean, that's really not, I shouldn't say upgraded. We have different. Whether they're upgraded or not is a value judgment I'm not going to make. Now the legs are splayed a little bit on this, and we want them straight instead, so I just take my needle nose pliers and take that little bend, that double bend out, and that allows us to put them in correctly. Now we're matching the gray stripe on the back to the flat side instead of looking for the long lead, particularly since we cut these out of the tape, so the long lead is not longer than the other one anymore. And where does this go? Goes, here it is. And I believe those are the last parts to go on because all we've got left are the knobs, switches, and jacks to go on the other side, but I want to go through the picture again and verify that. Make sure I'm not missing something or I didn't drop something on the floor, which is often more likely. Oh yeah, we still have the power connector to do. So I want to make sure we got these all right, and we do. I'm gonna solder these, and then we'll put the power connector on. And now we'll do our power connector, which is in this other bag, is it not? Yes, it is. Now you can see it's got negative 12 volts there, which is the red stripe. So we want to make sure this aligns that way. So we'll take power connector with keying on it. And that's not right. So we'll switch it around. And now the key puts the red negative 12 volt line in the correct position. He's got a little clip on the corner of the connector on the silk screening on the board. It's not on the connector itself, so that if you're looking for a little clipped corner on the connector, you're not going to find it. So just grab where's the little piece of foam? Just grab a power cord and put it in and make sure the red stripe is by the side where it either says red stripe or where it says negative 12. And I'm going to put a little piece of foam there to keep that in place for myself. And I'll do one lead. Pick it up, take a look at it, just to make sure it's flat. I'll just press on it with my index finger behind the board and then reheat that solder, and no, it was fine. But it doesn't hurt to double check. And that is everything on the component side of the board except the ICs, which I'm going to put on after I put all the pots and knobs on. Just my way of doing things. I'm going to go through right now and make sure everything is actually soldered and I haven't bridged anything. Using an index card or a card so I'm not distracted by looking at the whole board at once. I'm just looking at one line at a time. Is that much soldered? Yeah, it is. So that looks good. Now we're going to populate all our pots, jacks, and switches. We've got 100K, B100K. I think this goes up top. Sure does. More 100Ks. Let me see if he's got a picture of that. Yeah, he does. Yep, he's got a picture if you want to be sure you're getting all the guys in the right place. Oh, he's got an A taper in here too, huh? Interesting. Where does that go? That's interesting. Is this the A one? Oh, it is. I put the B one into the A. They're different tapers. One's linear, one's audio, and you don't want to get them mixed up. And I almost did. It's not catastrophic if they get mixed up. It just won't behave the way you quite expect. I'm looking for the B104s for the 100Ks because that's a 1 with a 0 and 4 more zeros, which makes 100K, 100,000. And we've got the 1 10K, which is a 103. Makes sense, right? Because that's 10 plus 3, that's 10,000. That all went in well. There's no LEDs on this board. There is this little switch, which will just kind of rock around in there. Then we'll put all our, well, I'm not going to put the switch in because it's just going to fall off. And I'm going to put all our jacks on. Now I'm going to put the switch in place. And we'll get the front panel. Drop that on. The only problem we're going to have here is the switch. I thought so. I knew it'd get loose on me. So I'm going to get the switch pedal through first. There we go. Now I'm going to grab my little clamp. Somebody asked me about this in a comment the other day. This is brand name is Wolfcraft, and I got these at Home Depot in the United States. Just look for Wolfcraft spring clamps and you should be able to find it. Now I'm going to do what I usually do, which is I'm going to get a slightly thicker piece of solder. Do I have one? Do I have one cut? Nope. Grab one here for the support legs of the potentiometers. And I'm going to solder this potentiometer support legs. And then I'm going to solder one of these jacks, and they're very tight, so they're flush against the board already. And with those things soldered, I'm going to grab one of the paddle nuts, put it on there, grab my 10mm socket, run that down. I can pretty much tighten that all the way down because it's not going anywhere with that leg soldered. Then I'll do the jack down here, put a panel nut on that, and use my 8mm for that. Now we've got one soldered and nutted here, one soldered and nutted here. That means I can get rid of the clamp. And now I can go through one thing I am going to have to do. As you may see here, the switch is kind of flopping around. I could put a backing nut on there, but I'm not going to because I get irritated by those. So what I'm just going to do is put a piece of foam under there, and that pushes that switch flat against the circuit board, and I'll do its connections. And get rid of the piece of foam again, put it in my little foam pad pile, and now I'm going to solder all the connections for the pots and knobs and jacks, you know what I mean. Now with all that soldering done, we'll go ahead and put the ICs in their sockets. And I'm going to go back to the line drawing to make sure I get this perfect. And we're going to put the 32055 up here. Where did I put it? I didn't even bring it over. It's only got 8 pins. It's an interesting package. And we'll make sure the notch goes in the right direction. I don't even know if I have to bend these inward or not. I think I will a little bit. Now we'll put the rest of the panel nuts on. And now we'll put the knob on. Make sure it's fully counterclockwise. Power cord in, and there we go. That's it put together. That's the front, it's the side, the back, the other side, the top, and the bottom. Now let's put it in the rack and see how she sounds. Okay, we're in the rack, and as you can see, I actually powered it on because I wasn't thinking. And a very interesting thing here, if you look on the meter, where's my... It's pulling 9 milliamps on the plus 12 and 4 milliamps on the negative 12, which is really low. Peaked at 11. Let's look at the 12-volt peak. The 12-volt peak was 6 milliamps, so that's really efficient. That's pretty cool. Now, I've got a Edu snare drum going into it. That's what the build guide actually suggests. He says give it a try with something percussive like the snare drum. So I had it hanging around, so I've decided to do it. So dry is all the way dry. Everything is pretty much set low, and we can hear it. Typical snare. Let me tune it a little bit. This is a really good snare, by the way. And my clock signal for that is coming from where? I gotta remember. That's the blue wire, which is 3. So now I'm going to turn in gain up a little bit. I'm going to turn dry wet to about halfway. Then I'm going to open this up. There. Can you hear it starting to delay? You hear kind of a double hit, almost a triple hit. Turn this up a little bit more. So that's what it's doing right there. You take it back to about here. I'm going to turn feedback up a little bit. Now we're getting kind of an echo effect. That sounds pretty neat. Turn this up a little more. We turn time down a little bit with the feedback. That sounds pretty neat. Let me turn it completely dry again. That's what it sounds like, dry. That's 50% wet. Let's go all the way wet. Oh, that sounds pretty neat. Actually, that sounds pretty neat. Let me turn feedback all the way up. It will certainly feed back on itself, won't it? I'm going to turn in gain all the way up. I'm going to try feedback right here. I'm going to turn range to long with the switch. So you can hear, there's the hit, and the delay is really delayed. I'm going to turn the delay all the way up. Now see how far away that is from the original? That's that. And that's that. Turn feedback up again. That's pretty neat. Now I'm going to switch the output to the wet out just to see. So that's just the completely wet signal, which is just great. I'm going to go back to mix out. And then I'm going to take my LFO and put it in time CV and see what that does. Switch to short. Speed back up a little bit more. Now I'm going to go into inhibit CV, which I don't know what it actually does. And as you can see from the symbology, that's a pulse. So I'll come out of the pulse on the LFO. I'm using the Cycles LFO from somebody or other. It's on my channel. You can look it up. I'll include it in the description maybe if I remember. It's a real good LFO. So that's what the inhibit is doing. I'm going to take time CD out. So when it pulses on, it adds it in. I'm going to turn this up a lot faster. Off, on, off, on, off. So that's pretty neat. I'm going to take that back out, but you can see what that does. That gives you some sonic flexibility there. I'm going to turn feedback way up again. So that's what it does with a rough sound, a percussive sound. I'm going to try it. See, listen to how much variety you get in there. better on long. Now that's actually not being gated, that's just the raw signal, so let me try and put a gate in there. I can remember what the heck I'm doing here. The clock is going out to, coming out to there, and that's coming from there, so I want to go here. No, that's not where I want to go. Hold on, camera skip or audio silence as I sort things out. Okay, now I've got a VCA in there to give it more percussiveness. I'm going to turn this up pretty fast. So actually I could sit here and play with this for like an hour just playing around with it. It sounds really good. As you saw, it's a pretty straightforward kit. There's some, when you're soldering the pots and jacks on, there's some tight soldering you got to be careful of. But other than that, went together pretty well. And again, it has a fantastic user guide with it. And this is the Bucket Brigade Delay from MKI and Erica Synths. Another good unit from them. And I hope you enjoyed the video.